we kind of cracked the nut on language generation, where we now have models that have kind of a whole understanding of how language works. I think we're progressing to a state where using visual inputs, we can understand how the world works spatially. And I think that has phenomenal impacts for understanding and modeling the world around us.
Welcome to Unplugged, the official podcast of the Poultry Science Association. This is the podcast where we strip away the fluff and get real about poultry science from bench to barn. I'm your host, Andy Vance, Executive Director of the Poultry Science Association. You know, we talk more and more in society today about the role artificial intelligence plays in so many aspects of daily life, whether you are a university faculty member, somebody working in industry, or you're just curious about what your kids are learning at school. AI has probably been part of your conversation at some point in recent history. In the poultry industry, no different. In this week's episode, we're joined by Walker Bynes, research engineer at the Parker H. Pettit Institute for Bioengineering and Bioscience at Georgia Tech, who's going to help us explore the intersection of robotics, AI, and lab automation in poultry science. With his background in mechanical engineering and computer science, Walker brings some deep technical expertise in robot planning, software engineering, and increasingly into embodied AI. His work on biomanufacturing automation and stress detection in crop fields showcases some of the innovative solutions that are possible and that could shape the future of agricultural and poultry-specific research. Walker, thanks for joining us. I'm a big fan of what you and your colleagues there at Georgia Tech would do. Listeners to the program will know Colin Usher talked to us about robotics and some of the things that are possible in poultry houses. I really want to drill in on your expertise in robotics as it relates to this conversation of AI. Could you give us maybe a broad overview, your elevator speech, if you will, about how robotics and AI are working today and how it connects specifically to agriculture and the poultry industry?
Yeah, so thank you so much, Andy. I am the lead of the machine learning and data analytics branch within my group. My team and I work in machine learning, AI, and data science technologies to kind of broadly improve the human condition. So a lot of that is in the domain of agriculture and poultry, though as well, we also work a lot in biomanufacturing and healthcare, as well as energy optimization and alternative fuel sources, chemical and biological safety, and systems engineering, in addition to the work that we do in the poultry industry and how robotics, embodied AI, and intelligence can provide significant benefits to various parts of the industry.
So let's start maybe with a level set. In the context of agriculture and poultry systems, what is the state of adoption, the state of our knowledge, our understanding? What's happening right now with regard to how the industry is using robotics and maybe AI specifically, or how those two things work together?
Yeah, I think that it really varies a lot depending on what part of the process you're in. I think that if I was going to generalize about the industry as a whole, I would say that to a large extent, the industry is in the fixed automation progression of technology, where the way we see it, there's fixed automation designed for a particular purpose. You build a machine, hardware, software, electronics, to solve a particular problem, and it's specifically designed for that problem for maximum efficiency with maybe limited flexibility or generalization. Robotics attempts to take a more generalist or flexible approach of, can we use a robot arm or a quadruped or a humanoid robot that can do more than one task, either as good, as better as a human, and provide more general and scalable solutions than needing to design a new machine every time you want to make a change in your process or have a new capability in kind of the automation space. Where AI fits into this, AI and robotics are kind of on a collision path with one another. There are still people in robotics that don't do AI. There are still people in AI that don't do robotics. But increasingly, that Venn diagram is seeing more and more overlap with these more complex robot systems, these higher degree of freedom systems, so quadrupeds, so humanoids, much more complex to control than, say, a single fixed robot arm. With that higher dimensionality, as well as an increase in the number and the quantity and the modalities of sensors that are included in these robot and intelligence systems, increasingly the technology industry is leaning more on AI to understand that high-dimensional, multimodal, complex data and how it can be used to drive decision-making and also to control embodied agents like robots.
Yeah, I was thinking about as you were describing the traditional, that fixed robotic application. I was going back to maybe right or wrong, but the metaphor in my head was maybe an assembly line. Okay, I've got a robot that's doing this one task on the assembly line as we manufacture the car, or maybe a small set of tasks. They're repetitive, they're always the same, doesn't require a great deal of thought to say attach X to Y. That's kind of what you're talking about with that fixed purpose robotics. So maybe that's
There's a bit of a overlap. There's not a clear black and white distinction between fixed automation and robotics. Typically, what we're trying to pursue on the research side and with new technologies is building systems that are more flexible, more human-like, that
Mhm.
can do multiple jobs, fill multiple roles, and make decisions in real time instead of what we'd call fixed automation, whether it looks like a robot arm or it looks like a gantry system or it looks like a conveyor belt with several different bespoke machines doing different processes. Each of those is purpose made, purpose scripted, and controlled to do that one task. Flexible and intelligent robot systems may not be as maximally efficient, but what they may lose in efficiency by not being purpose optimized, they gain in flexibility and scalability. So instead of you needing to design a new machine for every task, you have a suite of robots that you can redeploy, reprogram as demand changes, as the needs for your product changes, how many houses you're running, how large your houses, as the technology progresses and has the industry and the process changes, you have that flexibility to redeploy, to redesign, and to reprogram for different tasks.
I'm curious a little bit about your journey, Walker, because you mentioned, like you have people who do robotics, you have people who do AI, Venn diagrams starting to overlap more. You did your undergraduate studies at Georgia Tech in mechanical engineering, your graduate studies in computer science. How did you get into this space of working in agricultural systems? You mentioned some of the other areas where your team's working, but how did you get engaged in the biosciences and then the poultry science world specifically?
For the poultry industry, I don't have the kind of the classical agricultural upbringing. I grew up on a farm, raised chickens, always knew I wanted to work in agriculture. I kind of started in the technology space and then thought, what are some very challenging greenfield problem spaces and domains that leverage cutting edge technologies, but that can solve a kind of real world problem? And that's what kind of drew me to agriculture, as well as some of the other domains we work in, like biomanufacturing and healthcare, in that working with natural products and in natural environments are inherently significantly more challenging than, say, an assembly line. With an assembly line, you always have the same parts with the same dimensions time after time after time. If you're working in a crop field or you're in a processing plant, all of the birds are going to be slightly different sizes, shapes, weights. There's going to be defects. If you're out in a field, there's going to be changing lighting conditions, weather, issues with soil. So it's kind of a domain that doesn't lend itself as well to fixed automation. And so there's a lot of opportunities for intelligent embodied systems to make a difference in this area. And then there's the impact part of it. Being able to say that I work in an industry that's pushing to have a more secure, more affordable food supply for the world's people, I think is also very rewarding versus working in a different industry that's, making consumer electronics or disposable goods or things like that. Everyone needs to eat. And so being able to help resolve the problems that the industry faces with providing enough healthy, sustainable food to meet the demands of a growing population is also one of the things that kind of kept me in this space for so long.
Well, you may not have had the traditional background you mentioned, but speaking as a Southern Ohio farm boy, you sure articulate the mission rather well, Walker. And I think a lot of us can identify. That's why we got into agriculture in the first place, is that inspiring task you talk about. So I love your pitch there. Thinking about the challenges you highlighted, right? The disassembly line that we use in the processing facility, birds are pretty uniform, but not 100% uniform. That's a great example. And certainly we could be talking about in the production, the live production side, the various challenges there. So I'm curious as to how you see embodied AI and robotic automation used to improve efficiency in the production environment. So maybe we'll start there when we get to the processing side. I'm guessing maybe that's where some of the, I'll call it low hanging fruit, whether it is or not, but maybe that's some of the most readily available opportunities to improve efficiency. Is that a good guess?
Absolutely. I would say that the kind of obvious advancements or the lowest hanging fruit, as you would say, would largely live in the processing space as it's the most similar to a traditional manufacturing environment. However, from a research side, I'm interested in moonshots and trying to develop transformative and revolutionary technologies. So we're looking kind of all across the board beyond just robotics and AI, applying them in all areas of the production chain, from live animal care and animal welfare to processing operations, inspection and quality control, logistics and industrial optimization. And then AI can also be used for kind of your classical marketing and outreach tasks as well. They kind of affect all businesses as they operate.
You set the stage there really well. You mentioned your work in some other, I'll say, adjacent industries in the biosciences. Like, how are we doing in terms of, are we ahead of the curve, behind the curve, on the curve, relative to other similar industries?
It depends on what part of the process you're talking about, but I would
Mhm.
say specifically in the processing and the lab side, which
Mhm.
the laboratory automation and the laboratory components in the poultry industry, I would say are about on par from my perspective, as with other industries. Like take bioscience and biomanufacturing for healthcare. That's also an area that I work in a decent bit. We're kind of at the same fixed automation stage as the poultry industry, where when you're developing pharmaceutical therapies, specifically like cell and gene therapies, they have a fixed recipe, a fixed process that for the most part they have automated from a capability standpoint. So they know that we're going to dose this much media and give this much glucose to the cells, maintain things at this level. We're going to harvest after this time. We're going to follow this process and this recipe. But it doesn't have intelligence and reactivity and a changing process to focus on outcomes rather than the process. So it's very much in the same boat as poultry in that there's low level automation, but not necessarily a ton of artificial intelligence.
I think that's a good segue into something I was wondering about as you were talking about lab automation and some of the research opportunities. Good number of our listeners are working in poultry research, colleagues who are in a lab setting regularly. So, what role do you see lab automation playing in research in terms of how AI can help address some of those challenges that you referred to? What's the next frontier that we might be able to advance thanks to AI in the lab?
So the way I see lab automation is as a force multiplier.
Mm.
So adding lab automation and AI into a laboratory setting, whether you're focusing on genomics or biomanufacturing or quality control, biosecurity, regardless of the area, the way I see it is as a force multiplier. It allows you to do more with less. I don't envision any time in the near future that you're going to have fully autonomous biolabs that are doing end-to-end processing and novel discovery and research. It's certainly possible, and I would be happy to be proved wrong about that. But I see it as it allows you, the researcher, to make better use of your time by removing a lot of the repetitive, time-consuming, or unnecessary tasks that can be, for lack of a better term, outsourced to a robot or AI system. At the low level, robotics and fixed automation are really all you need to do these laboratory tasks. But what I think is starting to see more adoption, and that where I think the next kind of wave of laboratory automation and integration of AI is in the high level. So instead of how you do whatever laboratory test you're doing, it's what you need to do.
Mm.
So making decisions, analyzing data, building representative models of your system, identifying anomalies and defects, and designing kind of new experiments or formulating hypotheses. That's all areas where generative AI and artificial intelligence can make an impact and add additional value beyond what traditional robotics and fixed laboratory automation can provide, which is just labor saving. So now you can imagine an AI research assistant. There's a whole kind of subthread of AI that is looking at how do we build an AI scientist that can brainstorm, form hypotheses, build experiment plans, evaluate data, form conclusions, perform the whole scientific method. And while I think that there's a lot of work to be done before that's really viable in a commercial or large scale sense, I think that it is a very exciting opportunity for that has the potential to impact the laboratory areas of the poultry industry.
Walker, I'm curious along those lines. How much you made the comment there's work to be done there, and I think for a lot of us listening to this, we probably have a lot of learning to do as individuals. The differences between you hear a lot of the terms thrown out, right? Generative AI, agentic AI. You're talking about creating an AI scientist there, and I think a lot of our members of the Poultry Science Association in the academic space, in particular, are also struggling with this on multiple fronts. How do we use this tool in the classroom, as an example?
Mhm.
very different application potentially than what you're talking about in the lab. So obviously those are of a research appointment. Going to be very interested. How can I use this in the lab? And then at the same token, I'm sure you get asked a lot about things like the hallucinations from the large language models and so on. So I guess where I want to take you next is looking at the state of AI now. How much of what it will take to get us there, where you're talking about the future shaping, is just about people understanding what AI is and isn't, and getting the average person in the industry up to speed, so to speak? Like, how big is that gap between our reach and our grasp?
I think a lot of it is education, outreach, understanding, as you're saying. But what I will also say is that artificial intelligence is not a panacea. It's not going to fix all of your problems and then
All
make
right,
your
I'm out there. I'm out there. I was looking for the silver bullet, Walker. Sorry, I needed it to solve all my problem.
I think AI is an outstanding tool that can solve a lot of very challenging problems. However, at the end of the day, it is a tool and it may not always be the best tool for the job. I think that there's a lot of hype in the AI space right now. And a lot of that hype is justified because we've seen some very impressive technologies that are coming out of these Silicon Valley startups and the big tech companies that are changing the way that we do business and multiplying our productivity. That being said, I do think there are some areas that AI is not the most aptly suited. And I think you alluded to it with hallucinations. Just to be completely clear about it, AI, I think its biggest downside is it's largely non-deterministic and black box, meaning that even as AI researchers with a lot of these models, we don't have 100% understanding of what's happening under the hood. We can observe the outputs and modify the inputs and experimentally and empirically determine things, but we don't know exactly what's happening under the hood with a large majority of today's models. As you might imagine, with some of the latest large language and vision language models, they're scaling up to like a trillion different parameters and different weights. And being able to analyze that and understand how those trillions of parameters in that model can make anything sensible is a very daunting task. And there is a subfield in pure machine learning called mechanistic interpretability, which is basically a very jargony term for trying to crack open that black box and understand what's happening under the hood with these models. But at the end of the day, a machine learning model is a complex transform where you have your input data, whether that's statistics, whether that's vision data, whether that's robot observations, genome sequencing. It takes that input data and it transforms that to give you an output.
Mm.
Now, that output can be a classification in terms of discriminative or classification AI. For generative AI, that gives you a distribution from which you can sample to create new instances of that class. But at the end of the day, a model's only going to be as good as your data input. And so there's always going to be some amount of opportunity for failure, which I think people that are not in the AI community need to understand that it's never going to be 100% accurate. Is that a deal breaker? Oftentimes, no. If you look at things like ChatGPT, a lot of the metrics are qualitative. So if it's editing prose for you and it can do a good enough job to improve the grammar, to make things sound better, that may be ideal. But if you're in a scenario where there's mission critical decisions that need to be made and the cost of failure is really high, and the input is such that there is one right answer that you can figure out algorithmically, machine learning may not be the best approach.
Well, and I think because people like to focus on the anecdote of the failure and turn that into anecdata, they'll see the lawyer that turns in a brief that was written by ChatGPT that the judge laughs out of court, or the government report that had hallucinated references when it got sent to Congress. And people are like, see, I told you that this stuff was all. But to your point, there is something to be said for discernment in understanding what is the role the tool can play. It's a tool. It's not the tool, right? It's
Exactly.
so let's shift a little bit from maybe some of those pitfalls to innovation, insight. For you, what are some of the most exciting technologies in the AI space that you see emerging that have the potential to become game changers for poultry science and the poultry industry?
So given that my background is kind of hybrid in robotics and artificial intelligence, a lot of what gets me really excited about transformative innovations in AI is in things that can be applied to embodied or agentic AI for virtual agents, for robots, for beings, whether they be artificial or human, that can affect the world. So I think for that, the advances in multimodal generative AI specifically, so vision language models, both understanding videos and images, as well as creating new images and videos, is very exciting because of the applications that has for a robot or for an embodied agent. And there's been a lot of papers recently on using these to help construct plans for robots of generating a video trajectory for what the robot would need to do to accomplish a certain task, and then use that visual input to determine actions. Also, there's a paper that actually came out from Google DeepMind yesterday that investigated how video generation models can reason through problems, and using vision and video generation as kind of your thinking substrate, how you can solve mazes, how you can understand physical properties of objects, how you can basically do image or video editing or computer perception, all through AI generation. And they've demonstrated that with the VO3 video generation model, that that system has a fundamental understanding about how the world works that it expresses through video generation. And so we kind of cracked the nut on language generation, where we now have models that have kind of a whole understanding of how language works. I think we're progressing to a state where using visual inputs, we can understand how the world works spatially. And I think that that has, as you would imagine, phenomenal impacts for robot systems and for understanding and modeling the world around us. So from a robotic standpoint, there's even an offshoot of this called vision language action models that directly, instead of predicting words, they predict actions for the robot to do. End to end, you get your visual input and your goal in language. So if I tell the robot, drive down the hall and pick up a package that was just delivered to me, the model will then output the actions required to go do that.
What I find interesting there is I'm thinking about your colleagues there at Georgia Tech, and some of this will go back to our interview with Colin Usher earlier in the year, talking about some of the applications in the processing space, the cone loading robots. You have an operator with a VR headset on and a couple of gauntlets, and they're working the robot in the processing facility. Or, hey, we're sitting here and you've got an operator who's at a computer with a mouse clicking where the robot needs to make the cut once we get the carcass on the cone. What I'm hearing you say is that this is where maybe we have that opportunity that the AI can train the robot, that here's that we've seen that bird A is different from bird B, and we need to cut a slightly different place to separate that wing. Is that where we're going with this, that AI can help take that, maybe that operator out of that equation of, hey, you've got to click the bird with the mouse instead of just letting the robot do it?
I think that that's where we're headed. I think that the biggest gap that we have currently is data, because to build these, for lack of a better term, omniscient language models that have basically mastered all human languages, we have had to ingest all previously created written text for the most part. And it's taken unfathomable amounts of data to get to that point. And that data doesn't really exist in the robot space. So while we have a lot of these models, and the architectures are to some extent known, not the most optimized, but still known, we still don't have the data to be able to fully assess if this kind of global, mega large scale training can happen, because the data just does not exist. Now, what I do think we have the capability to do is for a task or domain specific model, like say a poultry processing expert or a live poultry house robotics expert, since those models don't need to know how to deliver packages or purchase a house or pay taxes, it doesn't need to do anything that's not related to the domain that it's living in. I think that we can get to that with several orders of magnitude less data. That being said, we still don't have enough data even to build a poultry house expert robot or a processing expert robot, at least using these architectures.
Well, and I think your point about the data is the potential with some of the visual things, video imagery is well made, but it's interesting just seeing how far even a model like ChatGPT 5, I was tinkering around one day. Our family's involved in dogs, and I put a couple pictures of dogs into chat, and it said, analyze these two dogs. Tell me one versus the other. And the feedback was interesting. There were a lot of things that it got right, and the things that it got wrong, I thought it just needs more input. It needed more data of me or somebody else who knew what they were talking about to say, this is what you're looking for. And then you train that model in theory. The possibilities are fascinating. Now, the Studying Mrs. Vance would shame me if I didn't ask this question, kind of the whole rise of the machines question. You talked earlier about our mission, the safe, abundant, affordable food supply. How do we, whether it's engineers, scientists, all of the interdisciplinary folks involved in this, how do we make sure the AI systems used in agricultural settings are reliable, safe, interpretable by the people who use them? What's the checks and balances that we need to see in those systems?
As I said earlier, the kind of main drawback about these large scale AI systems is that the quality of the output is only as good as the quality of the input, both the training data and the prompt. Additionally, they are inherently non-deterministic and black box, at least today. So I think that there's kind of two answers to your question. The first is there's performance understanding and performance transparency, where we need to evaluate these models for the specific tasks that they're being requested to do and develop an understanding of what are their rates of failure, what are their modalities of failure, and can we resolve those via prompt engineering, via fine tuning, or via guardrails to ensure that the model behaves in the way that we need it to do its job. Now, that's kind of the short term, which is largely education and outreach focused with a small amount of kind of standard machine learning techniques on top of that. And I think that will get you most of the way there. And then I think that the interpretability and the understanding of how the system's going to behave is, I think, the most crucial part. Because at the end of the day, if you have a perfectly fine-tuned model, there may still be some weird edge case that causes it to fail.
Yeah.
And having the language, having the understanding, the reasoning traces from the model, understanding how and why the AI model made its decision that may have led to the wrong outcome is both a challenging research question, but also an important question for users of these technologies to understand. Because if you get an erroneous output and you don't know how it was resolved, you don't know if you have a systematic failure or if this is a once in a lifetime edge case. So I think that it's a combination of quality control, extensive testing, and education.
Thinking as we get down to the last couple minutes we have together, Walker, but thinking about collaborations. You obviously have a really diverse team of folks there at Georgia Tech, engineers, computer scientists, people who specialize in robotics and AI and so on. What kind of interdisciplinary collaborations like those between AI engineers and poultry scientists, say, for example, do we need to see happen in order to move the industry forward in this arena?
In general, I would say that true transformative innovation will always come from an interdisciplinary team because those are where all of the challenging and all the impactful problem spaces lie is in interdisciplinary realms. So I think it's super critical that we as scientists, engineers, growers, plant managers, business people, etc., can all collaborate and share ideas and that we all have a common language with which to express those ideas because it's impossible for any one person or even any one team to know everything. My research group at GTRI, we have mechanical engineers, computer scientists, chemists, biologists, systems engineers, electrical engineers, but we don't claim to be poultry science experts. Whenever we need to get poultry science expertise, learn about genomics or about the specifics of a particular plant or like an anomaly in the data, we go to our collaborators at University of Georgia, at University of Arkansas, Nebraska, Georgia Poultry Lab Network, any of our other collaborators that we worked with either previously or currently to help gain that interdisciplinary expertise. And that's, I think, how we work together is through specialization and then collaboration. While I work heavily in support of the poultry industry, I would never claim to be a poultry scientist or a poultry expert myself, nor would I ever expect to know all of the intricacies or the facets of a particular plant or a specific flock. I will specialize in technology development and technology application, and then collaborate with the experts to know what are the hard problems in poultry and how do we apply this in the way to have the most impact.
Yeah, it's a fantastic approach. Your whole group there at GTRI really, I think, do a fantastic job of that, and is evidenced by all the collaborations and the partners that you mentioned. All right, last question we have together, Walker. This is what I call the crystal ball question. It's one of my favorites every week. Where do you see the biggest opportunities for AI in the poultry industry over the next, say, 5 to 10 years? What's got you most excited for the road ahead?
I have two answers to that question. One from a robotics perspective, one from an AI perspective. From a robotics perspective, I would say that flexible, reusable robots that can solve multiple tasks within a plant or within a house or within kind of any industry. Flexibility and scale in robot systems, whether that be humanoids, quadrupeds, whatever morphology you want to consider, shows the most impact because you then no longer have to build a new machine for every task. And if your demand changes, you don't have to have enough equipment to maximize the demand on that line or with that task. You can flexibly redeploy systems as they're needed and also upskill them with software if you have a change in your process or there's a new technique that comes about without needing to redesign equipment. There's a thought that robotics may be approaching an iPhone or a personal computer like phase where instead of all of us having different hardware platforms, we have one hardware platform with a shared operating system, and you can install new apps or new behaviors for different purposes. And that I think will just rapidly multiply the efficiency and the scale at which we're able to deploy robot systems if and when that occurs. In the AI realm, I think that one of the biggest impacts that it's had, both with the poultry industry and also across all industries, I think is the ease of information access and the democratization of domain-specific information. So while I think that current AI chatbots can struggle with hallucinations, or especially when dealing with niche or like very domain-specific nuances, I'm confident that those kinks will be sorted out in the next few years. And I could definitely see that while we may not have artificial general intelligence that knows everything at a superhuman level, I'm highly confident that we can get fine-tuned subject matter experts for specific areas, such as a poultry GPT that knows everything that you need to know about the life cycle, the processing, the production of poultry product.
It'll be fascinating to see how it comes together. Walker Burns, Georgia Tech, a really great insight into a rapidly evolving piece of our industry and some really specific and interesting, exciting opportunities in the research space, the scientific realm specifically. Friends, if you enjoyed this episode, I would encourage you go subscribe and give us a rating wherever it is you listen to your podcast. We're here each week bringing interesting people like Walker Burns to the table to talk about really fun and challenging concepts in poultry science. And on the AI space, stay tuned. Here in a few weeks, we're going to be hosting a Poultry Science Association webinar on the use of artificial intelligence in the classroom. Some of our leading teaching experts will be leading a conversation about AI use as it relates to teaching and learning. And I wouldn't be entirely surprised if at next year's PSA annual meeting in North American Scientific Conference, if we didn't see a workshop on artificial intelligence in poultry science. I think there may be one of those in the offering. Stay tuned for more about that. This episode of Unplugged was produced by Lindsay Johnston with editing and engineering by Michael Lunt of Parasol Video. Subscribe and rate wherever you listen. Come back next week for another interesting conversation. Until next week, for the Poultry Science Association, I'm Andy Vance.